In this video we want to have a look at spectrums or spectra. To begin, let's have a look at a spectroscope. Now, one of the simplest spectroscopes is probably just a simple prism. And what a spectroscope does is breaks the white light or a spectrum of light into the different colours which make it up, or the different wavelengths or frequencies that make it up. So you can see here the different colours which go to make up white light. Now, this is a very simple spectroscope, and one which is a little bit more advanced is this one. And as you can see, this is a diffraction grating spectroscope, and as its name implies, it uses a diffraction grating in order to separate white light into the different wavelengths. This is a diffraction grating which doesn't really explain what it is, but what you can see there is lines per millimetre, and what it is a whole lot of lines or scratches on a sheet of plastic, and what those lines are able to do is to break the white light up into its different colours, and I'll show you in a moment how this happens. So you can see the setup here. What I've got is a single slit right in the centre there, aimed at the diffraction grating, and so the white light passes through that grating, that series of lines, and produces a spectrum here. And I'll turn the light off now in a moment, and you'll be able to see the spectrum a good deal more clearly. So there you can see the spectrum more clearly, and you can see two spectra on each side of the central white band there. If I move that closer, you can see quite a clear or obvious spectrum. And this spectrum is much, much better than the one that we got from the Perspex block. Now, another spectroscope is this one, where you look through this aperture here, and the light comes through this slit here. Again, we use a diffraction grating to separate the light, or to disperse the light into its different colours. So with the spectroscope set up like this, aiming at a tungsten light, and the other spectroscope over there set up so that it's looking at the tungsten light, I can turn the light on and then have a look at the spectrum. Now, using this black spectroscope, one of the things that we can do is actually have a look at the wavelengths which are coming from the tungsten filament when it's alight. So what I'll do is I'll turn that light on, and then again we'll go for a tour, having a look through to see what the spectrum is like. So there you can see the scale and the different colours. So from that you can work out the wavelength in nanometres of the different colours. Now, the 7 that you can see at the right, that's 700 nanometres, and to the left you can see 4. So what you can do using that scale is actually work out the wavelength of the blue, the green and the yellow, or the ranges of those colours. So that's what the refraction grating is able to do for us along with that scale. What we can now do is have a look at the spectrums that come from different substances when they are heated to a very high level. Now what you can see here is a spectral lamp. It's a spectral lamp of hydrogen. So when there is a strong voltage or a high voltage between the electrodes at the end, what happens is that the hydrogen gas is heated and becomes excited as the hydrogen bonds break. That is, the covalent bonds holding the two hydrogen atoms together break as a result of the electrons flowing through. Then the electrons are knocked out of the isolated or separated hydrogen atoms. As the electrons fall back down, we find that they give out light. And they can give out light of different frequencies, but only certain frequencies. And these frequencies we can see via a spectroscope, breaking them down into the individual frequencies. And when we do that, we get certain frequencies or spectral lines. These are characteristics of the hydrogen spectrum. This is a helium spectral lamp. Again, when we turn this on and run electrons through it at a high temperature, we find that we get a glow coming out of this lamp. This glow, this light, can be passed through a spectrometer or spectroscope, and we again get a series of lines. That series of lines is characteristic of the helium spectrum. It's like a fingerprint. It is unique to helium. It enables us to detect the presence of helium when we see the characteristic lines of helium in a spectrum. For example, the helium lines in the spectrum coming from the sun. Here we've got another source of light from a different element, and I'll give you a clue as to which element it might be. And what we can do is have a look through each of these spectroscopes to see if we can work out, in fact, what this element might be. So if I look first of all through this spectroscope, then through this spectroscope, you might be able to pick out the wavelengths from what you can see there. And from there, you might be able to work out what the element is. Here's another discharge tube of another element. Again, have a look at the spectrum and see if you can work out what substance it is. To give you a clue, having a look now at another spectrum, this time from a different element. Again, you may be able to work out from the spectrum what that element is. I hope, as a result of this video, that you have learned, first of all, what a spectroscope is. Secondly, what happens inside an atom in order to produce the emission spectrum. Thirdly, that individual atoms or elements have their own unique, their own characteristic spectral lines.